In chemistry, we take lots and lots of measurements. And to take those measurements, we're going to be using the SI system. Now, the SI system is just a variation of the metric system. You're going to see, I'll show you a couple of the small changes why we call it the SI system. Um, this was first developed in the late 1700s, about the time of the French Revolution, and it's been adopted by every large industrialized country, but we kind of haven't adjusted or adopted it quite as well. It was made legal to use back in 1865, but we still have a tendency not to use it as much as we should. Now, you can get into a whole lot of issues about why that is. Just know that in chemistry, we're going to start taking our measurements using the SI system. Now, the great thing about the SI system is you have these base units and you can make them bigger or smaller by units of 10 by using a prefix. And we'll talk about those prefixes on the next slide. Now, there's 7 base units. We're going to talk about 3 right now. We'll add another one in later on. The first base unit we want to talk about is mass. Now, mass is measured in kilograms. Now, you might say, wait a second, that has a prefix. Kilograms is kind of an unusual one. That's that variation that we were talking about earlier. Some metric systems start with grams. We're actually going to use kilograms because it's a good unit, good size unit to do a lot of easy comparisons for us. This is the only base unit that will have a prefix. Now, keep in mind, mass and weight are different. Mass is the amount of substance. Weight is the gravitational attraction acting upon that. You'll get to see some more about that later on too. Length is measured in meters. Meters is close to a yard, so if you are more familiar with the British or the imperial system or the English system or whatever you want to call it, it's close to a yard. It's just barely longer, so a yard on me is from the tip of my thumb to just past the tip of my nose because I have short arms. A meter is just a little bit bigger than that. Time is measured in seconds. So on the next slide, we'll look at some of those units. Now, when you were in school, you may have learned about uh, deca and deci and all of these really, really weird units that only change by tens. Well, in chemistry, we like to have larger changes. And you'll see this is pretty common with a lot of the different things that we're going to talk about. So if you look at the prefixes on this slide, and these are the ones that I would expect you to be able to know, you're going to notice that they go by thousands, 1,000 times bigger or 1,000 times smaller. So starting with our base unit, so this none, that's our base unit. If we want things to be bigger, 1,000 of our base unit, so say 1,000 meters is a kilometer or kilometer. If we had a million, that's mega, and a billion is giga. Now, I have something that you're probably familiar with. You might not have realized it before. If you look at technology, either say cameras or computers, and you're going to store information, um, long time ago, you used to use megabytes. And then if you have something that's really, oh, let's go back, kilobytes. So if you look at a picture, it's normally measured in kilobytes. And then if you have folders and you have a lot of things in those folders, you get into megabytes. And then bigger than megabytes, you have, oh yeah, gigabytes. And what's bigger than a gigabyte? A terabyte. So the next 1,000, so a trillion of something would be tera. Terabyte, terameter, teragram, whatever the case might be. Now, if you want to go smaller, the first one we have listed is centa. And you might say, wait. You just said that we're only going to deal with thousands. But if you notice, centa is only 100th. There are 100 centimeters in a meter. And it's actually the centimeter that's the main reason that we actually keep that centa in there. So centimeter is the closest variation to an inch that we would have. So that one we do use fairly often. Smaller than that, we have milli. Milli is 1,000th. So there's 1,000 millimeters in a meter. We have micro, which is a millionth, so 10 to the negative 6. And we have nano, which is a billionth. Nanometers we'll talk about when we get to light, and also distances for like computer chips. They'll measure those in nanometers also. Now, another thing we want to be able to do is to convert one measurement to some other units. That could be from one system of measurement to another, so maybe from the English system to the SI system, or maybe it's within the English or within the metric system itself. For example, let's say that I had 48 inches, and I asked, well, how many feet is that? Now, I know that you could do that in your head. You'd say, well, obviously that's 4 feet, but how did you do that? What type of conversion did you use? Well, you'll say, well, I know that there's 12 inches in 1 foot. How could I write that to where it's easily understood so I could see as an instructor what's going on in your mind? Now, there are several different ways to do this. I like to do what's called unit cancellation or unit analysis, dimensional analysis, the railroad track method. There's a lot of different names for this. But what I do is I start with the measurement that's given, and I'm going to set up a fraction or an equivalency going from one unit to another. Now notice that this is in inches, meaning I want to have inches on bottom, and I'm going to use this particular equivalency to help me. I'm going to say that there's 12 inches in 1 foot. Now if it's on the top, we multiply. If it's on the bottom, we divide. My units will cancel out, and it's going to leave me with feet. So let's say 48 times 1, well, that doesn't change it numerically, divided by 12 gives me 4. Make sure to put your units on there, 4 feet. Now I'm not worried too much about significant figures right now because that's something that, well, I talk more about that in one of my other classes. I have 2 more examples on the bottom. Now these are ones you might not necessarily know that conversion right off the top of your head. So to help you, I have added a document called Common Conversions, and it just gives some just common conversions between the English and metric systems. Now usually there's a couple of different numbers that we could use. We're going to end up with the same answers no matter which conversion you use. So the first question that I ask is how many feet are in 100 meters? So I'm going to go to that conversion chart and I'm going to find some of those equivalencies. There's several that you could use. Let's see here. You could say that 1 yard is 3 feet. And 3 feet is equal to 0.9144 meters. You could also use the conversion of 1 meter equals 3.28 feet. Either one is going to give you the same answer, but let's look to see how we're going to set this up. You're going to start with the number that was given to you in the problem, 100 meters. We know meters are going to go on bottom, and what we're going to, in this case feet, will go on top. Now, just to make it a little more difficult, I'm going to use this top conversion. This idea that there's 3 feet is equal to 0.9144 meters. So I'm going to put 0.9144 meters on bottom. On top, I'm going to put 3 feet. And then I'm going to type that into my handy dandy calculator. I'm going to say 100 times 3 divided by 0.9144. And it equals out to 328. Just like that. The one on the bottom says how many kilometers per liter is equivalent to 32.5 miles per gallon. Now this actually has 2 conversions. We're going to go from kilometers to miles and then liters to gallons. So let's look at our 2 conversions we're going to use. We're going to say that 1 mile equals 1.6093 kilometers. And that 1 gallon equals 3.785 liters. We're going to start with the number that was given to us. So in this scenario, we're going to imagine that we're going to travel to, I don't know, someplace exotic that doesn't use miles per gallon. We're going to rent a car and it's going to be in kilometers per liter. Now I'm going to change this just a little bit. This slash right here, well, of course that means per, or it's over. So let's see here. I'm going to run out of room here. We're going to say 32.5 miles. Miles is MI, not just M. And I'm actually going to put that over gallons. Now the first conversion, I'm going to say that 1 mile is equivalent to 1.6093 kilometers. And then I'm going to say, let's see here, gallons is on the bottom, so gallons is going to go on the top over here. 1 gallon is 33 look at the right number here, 3.785 liters. Liters is usually shown with a capital L. Now when I type this into the calculator, I'm going to say 32.5. I multiply by what's on top, so times 1.6093, and then divide by what's on bottom, 3.785. The answer you get, 13.8 kilometers per liter. Now if I said we were going to rent a car that got 13.8 kilometers per liter gas mileage, you would have thought I was crazy. But it turns out that's about 32.5. Hey, that's not too bad.